So let's just see if everything works. I hope it does. And yeah, I think we are live. I hope it does. And yeah, I think we are live. Okay, perfect. My audio is also better than yesterday, hopefully. I noticed after the stream that my audio was a bit quiet, or I didn't speak as loud, my audio wasn't set up correctly. So, yeah, I just fixed that. I watched a few tutorials and set it up on OBS. Yeah, good. So the thing I want to ask you guys now... Oh no, actually, no. Sorry, wait, give me a second, I just have to set up my thing right here. But let's just see, that fits perfect. So, I don't see the live chat here on YouTube directly, but no, this, yeah, should do. So today we will continue designing our robotic arm, the finger for it. Yesterday we started by designing those parts right here. I was way too excited yesterday to put the stuff together, so basically I designed this part right here without the gear, and then also a gear, and the gear has just a knob on it which gets into the top part, and I stuck this together, used some Uhu glue to put it together, and yeah, basically that's it from what I done in the real life. Then this morning I got the idea that I don't have to like assemble this, I could just make it print in place. You see the marking on the hand right there. Wait, let me just... So, okay. So you see the marking here on the gear. And if we now go ahead and would stack this gear together like this, you see that it's only... The painted part is only the way the gears go, how far they need to go. So you see that I just pasted in my sketch here in Onshape, I just pasted the gear model in here and just cut out the parts that I don't actually need. And I only did this for the left finger, so we have to do the right finger as well. And I will do that for now. Oh, I will start working on that in the stream. I'm not sure how long the stream will go. I think I will stream for about 1 or 2 hours, and then I have to do some schoolwork, and yeah, that's it. So just paste this out here. I hope this won't crash. Oh, my PC is going quite hard at it. Nope, I think it's... Just close all the windows here, so... Nothing. Yep, no, I have to refresh the page. This happened also last time, I think it has to select way too many things. Yeah, let's just refresh the page. It's perfect. Okay, there we go, we're back. If I now go again in the top view and I just select that, let's see if I paste it on the right finger. Let's go on the top right here. If I press Ctrl V, nothing works. Yeah, that's what I thought. I will have to select the whole gear. Come on, man. No, I don't think that works. Okay, that's the thing about WebCAD modeling software. If the server there is not the best and my internet as well, then they don't fit quite nice together. Let's see, how did I do that before? Yeah, I probably wasn't streaming, that's how I did it. But maybe I can select them one by one, so it doesn't have to go through all of them at once. So select the first part, just go in here. To be honest, do we actually need the roundings? I mean, they're kind of cool, but yeah, I think they're taking a lot of the space. Oh yeah, I will shift. Oh god, I think it's easier if I just design the gear completely new on the sketch right here. So if I go into the sketch, then I will make a circle. This circle was 30 millimeters in diameter. Yep, that's about right. From the size. What's better like that? Yep, it's perfect. And now if what did we do yesterday? We got our line tool. We made a line like that. And here. Then we select the horizontal bar, just straighten it out. Then in the dimensions we set this right here to 3 millimeters if I'm correct. Let's just go in here. Let's just get a line from here to here. Okay, it's 5 millimeters. So we just need to adjust that to 5. Then it was 3 millimeters up here. And the radius from there to there was 60. This is also 60. Oh no, I can't adjust that. Was that 3 millimeters? I'm not sure. Let's just see if I can measure that from that to that point. Yeah, no, that was 3 millimeters. So that's how we go about this thing. I won't do the roundings for the edges. So now what we did was we removed all those and I pressed Control Save again. If we now select all those parts, let's hope that it won't crash immediately. Oh no, wait. The thing that was still there was this part, so we need all of that. Let's just go ahead and select all of these. And it's selected this, which we don't need. So if we now go around the object with this circular pattern tool, that's the pattern where we want to go to. Then at some point right here, somewhere I could select how far it goes. Somewhere I could select like 2x, 3x, it's right here. Perfect. So this we selected, I think, 18. Like this. If I take a look here, you know, it's if we no, that should be fine. If I press the mouse button, yeah, that works. So now what we do is remove all of those parts. Oh no, we actually need here the trim tool, and we cut out all of those right here. Takes its time. We can just continue the line. It's easier that way. Then we can also already select those right there. One thing we have to pay attention to is that we don't make them the same as the other side. I will explain in a second why that is. Why we have to do that. Wait. Let me just finish that task first. There we go. If we now go ahead and take a look at the left finger from the top, like that, and the right finger from the top, like that, we see that they are the same, like the same size, like the same position, and to have them not like they won't fit if we put those here, if we pull them together like that. We have to have a little of offset here. I did that by gluing them and making some glue on them, but before the glue drying out, I rotated one gear a bit so that they fit together. But I need to rotate here the peaks now, and I'm not too sure if how I do that. So let's see what kind of tools we have for that. Maybe let me search up a YouTube tutorial on how to do that. On shape, rotate, sketch. Rotate lines. Yeah, maybe let's just watch the tutorial and see.
To align these two lines, click on rotate. Select the object,
It's not on shape.
enter.
Example, I will create into on-shape drawing area. Now in here I will create example sketch in a top view. Click sketch and I will create a rectangle at this point. Click OK. Now if you want to rotate this sketch, you can rotate based on line. This is for line accurate. To the bottom you can click and drop. You need to, and for angle to line angle. For entities.
Okay, no, that's not what I need. Let's just see if we can find something out. Okay, let's go back in the sketch. Now what we need to pay attention to is there are some problems with now the rotary tool. Can I like make a line select? No. No, that doesn't work like this. Yeah, I know that some lines are not applicable in the current setup. Let's just create a few points here and also up here where we can put our lines to. So now we go into the trim tool again. Can just cut out these. That is good. The trim tool is still there. Trim that away. Oh, no. Wait a second. Like that. And here. Okay, there's not everything gone. Just no longer a face. Now we have a face. The thing with the trim tool now is that it still tries to go around the edge. Oh, nope. Go forward. I want to somehow no, that's not. How, man, how do I rotate this now? Revolute. No, that's an extrusion modifier. What's that doing? Mirror, I don't need that. Fix curvature. Construction, what is that doing? You see that I'm struggling here a bit as well. Like I said, I'm used to Blender and not the CAD environment. So I'm not really sure how to go about that. Just try and remove stuff we don't need here. It's no longer there. That will no longer be there. Good. So we have our like constraints. There was a problem with the tool that rotated our spike from the gear, and it was still trying to apply it, but obviously I cut out a bunch of the stuff. And now the thing I need to do is to rotate this whole thing in like some way, but I don't know how to do that. Unshape, rotate around a point. Let's try and see if Google has anything there for me. Unshape cat. Let's see. What is even that? Come on. Where did you get that from? You know, I understand. Okay, yeah, that makes sense. The revolute modifier is doing that. But it is cutting or adding something. I want to just rotate my sketch. I want to just rotate this right here. I mean, I really have to get some people that know a lot more about sketch modeling than me. Some like mentors or something. If any of you guys, I don't know if anybody's watching, but if any of you guys know a CAD modeling software and maybe can help me with that, would be cool if you can send me the DM. Maybe you can join my Discord server and just come in and talk with me. Would be really appreciated. So let's just see what tools we have here. Let's just try around a bit, and I could try to offset some stuff maybe. Okay, it doesn't make sense, the offset. I need to there we go. Don't want to save anything. How do we go about that? Well, the easiest way would have been if we could just go in here and just do that. But no, that's how you make your on-shape crash. And for some reason my PC then tries to kill himself, so that's perfect. So if that doesn't work, we can design the backplate for that, because after we have this fixed together, theoretically there shouldn't change anything other than the height of these and the removal of a bit of here. But we can already design the backplate where these will be mounted and the mount for the motor. Oh, no, it was selected, right? Okay, let's just remove that right here. We will try that again. We will just go to the top plate, and we will select that, and then we will select that. And here. And here. Just like that. So now we will just try our best to go in here, select everything, and bam. Please don't crash, would be very appreciated. Let's just take a sip of water, stay hydrated, guys. No, this time we want to wait in the page. You got this, man. Give it one more try. Oh, I told you. No, actually I didn't told you, but we got it, boys. So now we can, don't mess this up. There we go. It might look a bit scuffed because it's somewhere in there. There's probably some way how you can move this better than that. But what I will do, I will just works also. Make a 0 to 0, and now it's in there. What we can hopefully we still have to rotate it somehow. Oh man. If we select that, and I did the same. Okay, now we have our usual wheel in here, but that's actually not what we want. We want our wheel to be rotated. Ay. Do you guys have any ideas on how I could do that? Maybe you see something that I don't. Oh, that doesn't look right. If I can somehow rotate it around this axis right here. So some way, please tell me. Yeah, that would just mess everything up. I get it. Let's just... Okay. Unshape how to rotate a part. Oh, we watched this guy yesterday. He helped us out to build this gears. So maybe he can help us out again, rotating stuff.
Hello everyone, today we are going to learn how to rotate a part in OnShape. Okay.
Do you hear this twice?
Hello everyone, today we are going to learn how to rotate.
No, it's fine, it's fine.
For example, I will use this part. We're waiting to open the part object. Now if you want to rotate this part, you can use transform tools. Okay, click this icon, transform. The next, for entities, select part. I will select this part 1. For
wait a second, can I? If I don't paste this in here, can I make another sketch? Wait. If I make another sketch, select the backplate. Okay, that's... We got somewhere. So now if we go back into this sketch and we will just... Oh no. Okay, now I broke it. So if I go here, I can just select those points now. And like that. Up. Away with you. And there. And there. And this one. And our last one. Just like that. There was a point down here still. No, there's not. That's good. So now, if we go into the second sketch right here, and we just probably can scale that. Can we somehow make it dimensioning to here? From there it should be like 10. No, 10 not. Yeah. And now if we make this size from here to here, it should be also 1 centimeter, and we got this centered. Perfect. That's what we want, kind of. So it's already on that point. Now what we can do is take this part and make transform. Transform around that. Let's just watch the tutorial.
Translate by length, change into rotate. Now you can set for the axis, like I will set into this axis.
I can set the axis. That's awesome. So we will click on rotate. Then the axis is, I don't know. No, it's not the axis. The axis will be that one. The thing that I want to rotate is actually not that part. First of all, I want to extrude this out to 5 millimeters. Go into the extrude one. I want to extrude this. What is the problem here? Oh, I need to sit more straight. Okay, now this is kind of working again. So I just extruded that, and now I have extruded it twice. Not what I wanted. So we will build that face, and it will go to 5 millimeters, just as before. Okay, so we need to cut out the hole there in a second. I know where to go on this face. So if I make that visible, I can select this. Can select this. Nope. I can select this right there. Extend. I want to make it through all. I want to make it to remove this stuff. Wait, why can't I add a solid? Remove. I want to why can't I? Come on. Right, I can just go from the from beneath through all. Nope. Upwards. There you go, you can't trick me. So now what I want to do is open the window because my air in here is a bit bad. Not a bit, a lot bad. Sorry guys, today I ate a bit too many carbs because of Easter. So my brain is it's not working the best, but we got this, we boys. We just have to figure out how to scale everything and so selecting is a bit scuffed still. Maybe they will change that at some point. So I want to rotate this on. Where was it? It was right here, the transform. So that I want to. Can I remove that right here? If I now go ahead. Oh yeah, right, now the scaling is broken because there is no more point. Shouldn't be too bad. Now if I select this, it's no missing part, so there is nothing to merge with. So now I have to remove that one, I have to remove that one, and I will enable this face again. I will extrude that face again, 5 millimeters. Now the transform is still not working, so we have to select is there any entities want to rotate? This object, yeah. So, and we want to rotate this on the axis. Right there. We got it! We fucking got it! This took way too much work for rotating it 30 degrees. Oh man. So now what we do, we enable our thing here again, 5 millimeters, just as before. Merge it, that's fine. Now we select that point, make it extrude, solid, remove, and through all, and then we go. We got it. We actually got it, boys. When I did the last thing, the left finger, in like not even 20 minutes. I think like 10 or 50 minutes it took me to make that. This right here took like 50 minutes. The stream is going for 40 minutes. This took 40 minutes just to rotate it. I love it. So now, yeah, it looks fine. So now the thing that we have our, you see the grabber right here, you see the markings. If I just suppose to go this far and this far, so in theory we could remove all of these points, which we will actually do because we don't need them. So I will go into the trim and I remove all of the thing that we don't need will be removed. Let's take a quick look at the left finger, how much we removed at the top there. I mean, the last pin is that one, which is also the one at the top, kind of like the other pin. Yeah, no, that should be. Wait, this one was down there, this one is here. The pin up there is actually a bit higher. What's that one? Select. Yep. You know, we can remove all of them. Top here. Just make a big select. Let's just be brutal here and everything can be gone. And to the bottom, okay, I left it there. Theoretically you can just now rotate it like this far. But I mean, don't really need that. You actually probably don't even need like 90 degrees of rotating here. From here to here it's 90 degrees, which means that we should be fine with this setup. So now we enable this right here again. Enable those right here. We just quickly remove that one also. Then we plant a point down here and go there. That's perfect. Then we also want a point right around here. So from here to here, I'm not sure, I probably, yeah, That's the problem, it's not accepting that as a whole face. So we will have to draw also, or to complete the face here. We need to do that it's a face and not just a line in space that is one-dimensional. We want to have a loop there. So now if we... What do you mean with the... No, there is no missing face, shut up. Oh, please don't tell me it's everything is working. Don't tell me there's no missing part. Missing connection, there is no missing connection. Missing connection was here. Nope, you don't do shit right there. We can remove the transform. Wait a second. Wait. Please don't tell me, please. I think it's back to the old one. Why? Honestly, why? So we actually still need to rotate it. We can make a mate connector there. Rotate it on that side. Let's make it minus 930. Let's make it 15. Now we'd only have to rotate it in 15. Maybe 10. Yeah, 10 is also fine. Okay, this doesn't look as nice, but also works. Oh, I hate this. I don't want to look at it. Can I edit this? Hindsight now if I... Let's just close them for now. So this is fixed and this one right here is okay, it doesn't even look that bad here. Obviously down here it could look a bit better. It's not that bad. It's not. We can live with that. We can. So now what we do is we go on to the first sketch up here because we need to add something which is goes from here to down here. Is 4 millimeters long, like that, 4, and the diameter still fits because we need to lengthen it a bit. If you take a look at this here, we want to have it closed there so we don't have this little peak there, so we can just go on till here and then we're done. Just whoop. Pop. We got this, come on. This looks the same as here. I think we just have to You need to include the second extrusion here. Yep, now it looks right. We have it the same length as the gear stands out on there. So now what we do is we go ahead and click export here, which is right finger is fine. Let me just search the folder for exporting all my stuff. Projects, robotic arm, and right finger. Yes, I want to replace it. Left finger, export, and left finger. Yes, I want to replace that. Then what we do, we go into Cura, the 3D slicer, where we tell the 3D printer, or we create a file for the 3D printer to know where it should drive along. It's like this G code. Can we open it up? I have Visual Studio installed, yeah. Let's see how this file looks like. It's also interesting for me. I never opened this one up, but I can imagine that there are a lot of vectors where the printers drive along, and I hear my computer calculating a lot, so it's a big file, I think. So we have. Oh, this thing looks interesting. Yeah, G1, and it tells the 3D printer where to go. Oh, that's massive, that file. See that? That's a giant file. That's 2.5 hours on printing time. Right, I think we get under 2 hours with our current two designs, because we had the 4 objects that the 3D printer had to print at once, which means that he has to move between those. Like, he has some time where he needs to travel from the object there to the other object, which takes some time for the printer. Maybe just a few milliseconds, or not even, where you need to go from this to this, where you can print in that time. But if you add it up to like the whole printer, the whole time of him printing, it's actually a lot. Let's go ahead and rotate this 180 degrees. That's awesome. And now we can. That works. Could imagine that he crashes between those sides at some point. Yeah. Let's just try that. It would be much more efficient that way. So now 50% infill, lightning, slice. Yeah, 1 hour and 40 minutes. We are now exactly 40 minutes faster than the last print. Save to my 3D printer, and I'm back in a few seconds after the printer starts. And I'm back. Yep, just slid in the SD card and start the 3D print. Really easy actually. Also, the 3D printer was a really good investment for my father. We bought it, I think, 5 years ago, and I've used it. Okay, I haven't used it over the last 1 or 2 years much, but it's really cool if you know a bit of designing, you like engineering just like me. By the way, if you like engineering just like me and 3D modeling, 3D printing and electronics, then why don't you subscribe to the channel? I will try to make the best content for you so that you can learn a lot on the way, just like me. I will try to make a lot of videos about lessons that I learned from 3D printing, especially when I get the video out for my current, like the project, like the robotic arm. It will be really cool if I can teach some people like that and maybe wake up their interest in 3D printing. I can imagine that would reach a lot of people. Maybe also in the age like me, like 14 to 18 years old, just like me. Okay, I'm not in that age. I'm not multiple ages, but I'm 17 years old. And my goal is to build giant automation factories. Like for miniature things, like a factory that goes like all the way here in my room around you, give it in like a paper and spits you out, I don't know, like a cool paper house or something. Well, I would be so happy if I at some point would be able to design something like that and make it actually into reality. That is my goal with this YouTube channel. And if you know, I hope you can follow me with that. And I would appreciate a real like and a subscribe on the stream so that we can reach more people that maybe have the same interest, and maybe actually people that already know how to do that at some point maybe come in the stream and teach us some lessons about electronics and automation. I think that would be really cool for all of us. So yeah, now where we have this those printing, we have to do another paper prototype, or at least drawing a bit. So we will go into the video log. You saw the text. You can join the Discord server that I created. I created it, I think, last year. I've added a few new channels today, cleaned it up a bit. And what I want to do now is make a quick sketch on what we will design next. Yesterday we designed this little thing right here. That was our paper prototype, along with our paper cutouts right here. They were kind of unnecessary, but also cool to do here. The same tools, just in paper form. And my goal with this 3D printer is, with this arm, is like, I know that not everybody has a 3D printer, which is also kind of expensive. So they're so basic, those arms, that you could theoretically design, just print them out with a normal printer, put them on like wood or paper, or like I have a big cardboard box right there where if I buy something online, I just put my cardboard in there, so that if I make like prototypes or something, I just cut out some cardboard and just get some rapid prototyping in there. Yeah, so what we want to do now is the back plate for the robotic arm. If you look at that, here our finger or hand can just be freely, it would just not work. So we need something to hold them together. Now we actually have some holes in here. They are 6 millimeters big, if I'm not wrong. Let me just check that. If we go into the sketch right here, it's 6 millimeters thick. So we now want to have a back plate where we have the same properties. Maybe we will wait for the end of the 3D printer before we... Yeah, no, we have to wait on the 3D print anyways. So we don't actually know the distance between the points yet. I measured it before and tested it out a bit. I think it's around 3.4 millimeters. From center to center it's 3.3. Wait, I can just... I have an awesome tool for that. That one right here. I don't know how you name it in German and also not how you call it in English. Electronic digital caliper. Caliper? I don't know. If you know the name, tell me in the comments. So you go in here. You see you have like a display on here which tells you how far this is away. You usually use this if you want to measure something. For example, you have this servo motor here which we want to design in Blender or here in CAD model for holes where you want to stick it in, for example. And now you can just go it on here, and now it tells you it is 12.6 millimeters long, and there it goes. Really cool tool. I stole it from my father once. But he has like 20 of them lying around, so that's really cool. So what we want to measure is the distance between the inner point of that hole right here. Oh, you can't even see the... Let me just make it a bit darker outside so it color saturation. I have an actually cool camera right here, but I need to buy a selection cable or a connection cable for my PC. There is like a micro HDMI cable, and I don't know how to call this connection. But I have these cables, but they're only loading. They're, I don't think, data transmission cables. And then I also have to buy get a software. I think it costs. It's also from Canon. It's a Snapshot SX 540. Okay, it's not focusing perfect. Okay. Pop. Yeah, it's not. I don't think that the face cam is the best camera for that. So yeah, we need to go from that point to that point, the center, to know the length of how far the gears should be separated in the measurement. So it's a bit too close. Yep, just like that. 34 millimeters. So we will design another, create part studio. Also disable the front and the back plate. Oh yeah, and you can also tighten it, so I cannot move it here with the screw up here. Such an awesome tool. I use this in so many things. I mean, you can also do it with like a normal ruler, but it's not as accurate and not as cool. It's the main part. As if we do that with this electronic caliper. Wait, do I pronounce that right? Let's see. Caliper, like that. Oh, it's actually Bremssattel. Okay.
Caliper.
Caliper. Yeah, sounds good. So, well, let's always have like the transmission on and then back. Yeah, this video helped. This video, I tell you, this guy, he gets a subscribe. He helped me yesterday create the gear here, and it's a good guy. Also an Indian guy. So I found this so good. All the Indian guys I see on like electronics, on programming, you watch a video from them, they are always good at it. I think I never found a video that didn't help me from an Indian guy. So good. Yeah. So let's go. We want the length of that. There we can use for that. I will most of the time use for like approximating the size of things, or thinking what the size should be. I thought maybe about 8 centimeters, 80 millimeters in diameter. Okay, let's just start by making a new sketch, selecting the center point rectangle, and now we will just select that and size this up correctly. Let's first make the horizontal 80 millimeters, and in height we want to, I think 3 millimeters is fine. Not 25 millimeters. Not 3 millimeters, 3 centimeters. Yeah. So let me just check on the 3D print so that it didn't crash or anything. The first 2 layers you always have to check. Okay, the check-in was really worth it. There was like a big clump of a big ball of I don't know you call it, of 3D filament, and it was like stuck on the one of the parts. I just, with a little clipper, I just got it off. So yeah. So where were we? Here. Now we want to create the 2 knot holes, because we want to have, we want another one right here. Then let's set the diameter. We want them to be 5.5, because the 3D printer has a bit of error margin. I give it usually in those holes 0.5 millimeters of error margin, so if I have a hole and I want something to go through there, then I will make the hole 1.5 millimeters bigger, or the bolt that goes through it 1.5 millimeters smaller. In this case, we will make this 1.5 millimeters smaller. Now we just need to scale it correctly. Here we want a size between them of 34. Perfect. And we want them to be in the center. Okay, then we will make another sketch like that, which is 15 plus 2 is 17. 17 times 2, yeah, it's 35. Your math is calculating. Not the biggest, not the fastest head calculator. Oh god. So I think it's already from the height. 12.5, yeah, that's fine. Let's just go ahead. And I did it wrong, of course. So what we want to do is extrude them up here. I want this to be no, not another 2.5 centimeters high, millimeters high, sorry. And so this part, come on, here, like that, like that. You see, I'm still struggling with the 3D orientation. No, you actually can see that because I didn't stream it, because I just streamed my face. Yeah. So select this extrusion. Now the thing that we want to select is those two circles. Oh, come on! I really need to maybe invest in like Autodesk or Fusion 360. I think Fusion 360 is also free, and there's a large community around that. Fuck this, we just gonna redesign this, get more muscle memory in with the designing of these parts. So now we make a new sketch. The sketch will be selected up here. Then we go into the sketch, and then we want to make little circles there that are this big. Same points. We scale them up to 5.5 millimeters. 5.5 millimeters. Then we will scale them 34 like that. And up here they will be scaled 12.5. Just get that out of the way. And then 17 here, perfect. Don't know why these are back there. And that, there we go. I think now there should be Not sure, but okay, we have to redo that. Perfect. 5.5 millimeters. From the top they are 12.5. 12.5. From the center they are 17. Now we will have to delete that one as well, as I see this. And also from the center, it's fine like that. 5.5 diameter. But now here we go and nope, so from the center to the top they are 12.5. Scale this up correctly like that. Then we will make a 17 also out of that right here. 17. And we should be set with that. We can also, just for safety and for usually you give like both measurement, like the measurements, right? The measurements from the center to the object, between the objects, and then on the outside. But I would love to do like technical drawing. So if you have any good courses on technical drawing, I would really like to take a look at one. If you have any suggestions, or maybe went through one. I know that if you do electronics in school, you do technical painting, I think it's called. Damn. So technical painting. Drawing like this. Technical drawing. Yeah, imagine how cool that would be if you can have just this object and you can just design it and don't have to make it kind of out of mind like I do. And no, I don't want to make another sketch. I want to make another extrusion. This and this. And this, because this is 5 millimeters big, and I also want to make another shield on the back. I don't know what would be the best. 2.5, 5 and 2.5 on the top. You have like 5 plus the 2.5. Let's make it 2.6, 2.65, 6.5, and there we go. If we now take a look at that extrusion, could have just typed that in as well, but so this is our back plate. So this will be stuck through them, that they will be whole together, that I can't do that. And then we need to make a top plate, which is just the second sketch. Let's just rename this first. Hand holder, and bottom. Let's make another part studio. And top. Now we can just go ahead and copy the sketch right here. I hope. Of course we cannot do it that easily. We will have to go on the sketch like that. Then we will select everything with a rectangle. That's thankfully easier. Create a new sketch. Get our plane in there. Why that's to the center like that is, I don't know. Let's just make that 0. Then we will delete that because it is centered. Now we can go ahead, draw to, it's not centered yet, we haven't centered it in the Y position. We create a circle with C. I wanted to learn the shortcuts anyways. Now press D for setting the dimensions. The holes will be 6 millimeters in diameter now, because remember we now want to have like the bottom plate. This has the 2 holes, and those holes for the top one, they need to be a bit bigger because of the error margin. And then we can just put hot glue in there, and not hot glue. Yeah, we can try it with that one, and then I'll probably print this again for the video with like better filament like white or black, and see if I can design it not in this ugly just orange. I mean, the orange is kind of cool, but it has to be a combination with kind of black, or yeah, black or white would be good combination with this orange. So now also here for 5, 3, 4, 34 millimeters, dimensioning again in this 17, and then we also do 12 here and 12 here. And then just because we have the time, we go and size this up on this axis, 17 millimeters, and there we go. Now if we want to extrude the sketch, we just go 2.5 is good, but we want 2.5 for the top plate to not have it too big. And there we go. That should be it so far. Oh, and it's raining outside again. So going to the gym is today, will be a grind day. Not in the fitness sense, but in the business sense, if you catch my drift. So 1.5 hour stream is done. Let's make another 1.5 hours out of it until the 3D print is finished. In that time we can think a bit more how we should go about putting on this 9-gram servo motor on there. So on the bottom plate we can just mount him somehow, and then make him what is the best way to go about that? Probably if we mount him directly would be the best. If we mount him like that, and then we can, yeah, zeroing him. Let's just put the test together. If we have our plate up here, some way of sticking the servo motor through there. Oh wait. We have the rod sticking through here at that point. The right motor. What would be the best way to go about that? I'd probably say to just still mount it there, but on top of the other plate, and then we just need to somehow connect this top part to this down here. Put the servo motor like that we have a nice angle on here. Make a servo motor stand for it. Screw some kind of hole into that. Screw this hole into the back of the servo motor. I mean, hot gluing it on top would be the coolest idea. But I don't think this would work too good. I'll take a look at the 3D printer and see if I find something to eat, because I'm kind of hungry right now. And wait, let me just put this away before I forget about it. No, not tightening it. No, that is opening, rotating it to the left. So, like this. Close it. Always putting your gear away. Clear room equals clear mind. I'll see you guys in a second. I'll keep the window open so. Hopefully it's not raining inside, but Hey, and I'm back. Don't know if anybody's still watching or has watched, but the 3D print is still watching. Is still watching. What? Is still on there and working. So now we need to figure out how to actually mount the servo motor. When we actually have the parts so far, we can have this plate. We could mount the servo motor. It is okay. Then it's best if we make the plate a bit bigger. Let's make the plate twice the size. Not twice, but let's make it 3.5. $17.5. Okay, that's already set, I think. So this will be also 35 millimeters. And of course the next hole is a bit wanky. 17.5. Perfect. So if we mount the servo motor on top of there we need our good tool again. We can just go ahead, put it up. Wait, I will adjust the camera for you again. So if I move the camera down like that, you are able to see what I'm thinking and whooshing my hand around when I talk like yep. So servo motor, it is 22.7 millimeters wide. So let's make a sketch on top of here. We need one mounting port. Right here. And one right here. So from the center of that hole it should be $27.6. Okay, 27.6 divided by 2 is 13.3. Yeah, I could have thought of that myself. Oh, I halfway did. So now from here. Why is there no point? Come on. Like this. From here to here. It is 13.3. From here to here it's also 13.3. And from here to here in this sense is 0. Immediately remove that. Zero, center it. And we need this to be 12 millimeters. Also 12. And then right here we want this 6 centimeters, 6 millimeters. And this also 6 millimeters. Like that. Up. And on top of that. Okay, now we have to be a bit creative on how we go on how we go about mounting these things. We could have another port. No, we cannot because the arm is moving there, so we only have this spot. And if we create it like that, it's 3 long. So maybe have another point right there where we could fixate the port. Or on the outside we can maybe make some clips or something like that. So this could work. Anyways, I think it would be good if we can, if we have our, let me just take a look at the face cam. If we have our point right here, you see that? I need to hold my hand so the light won't mess it up. We have our normal hole on that side, but the servo motor will be on that hole, and that should then be way bigger. If you understand what I mean. If I hold it here, this will be our normal hole, and this will be where the servo motor is mounted. Right there. This is where the servo motor is mounted, which means that servo motor is mounted there. Yeah, so there will be a bigger hole, definitely. This, how tall this hole is now will be determined by the servo motor. We have the height of our constellation right here. Make it 14 millimeters high, but then we need to also subtract the 2 millimeters of the size right here. The size right here. I really wanted to point at the screen. That's not how this works. Minus 2.5. No, 14. I wanted 14, not 13. Works like that. And then we want to have some holes. I have two M screws, two machine screws, size M2 machine screws. I bought a set for them, which means that I can make a sketch that goes on this and this and that. Okay, then we make that one first and maybe the two. Wait, I'll just get one of these screws to not make any mistakes in the size of them. I don't think I have my screws down in the workshop. And I don't have them up here. Which means I have my screws somewhere in this room. Yeah, let's go, let's search them. Where the fuck did I... Sorry for swearing. Where did I put these screws? Oh, come on, I just... Oh, come on, no. There we have them. I forgot them in the wood workshop. So let's see what we got here. We have M2, M3 and M4 nuts and bolts. So let's see which ones fit here to the servo motor. Okay, I think it's only the M2 screws which fit through there. Can try the M3 screws. M3 screws. You know, it's M2, which are the smallest that I have. Only problem is it won't. It probably is able to. And we make the holes 1.5 millimeters thick, so that we can get still some grip with those screws. Yeah, let's see what we can do. Let's first center all of these. We make those to but how big were they? 2. Six. Okay, so they're 3, and then there's 6 again. So like that. Do the same thing for bottom, and then 3 center. Now we will make this 1.7. 1.7. And now we have screws that I have multiple sizes. I think this one will be the best. It is the I think 12 millimeter variant. Yep, if we make those holes 12 millimeters wide, this would be the best size. Yep, that's 12 millimeters as far as I could see. Yeah, wait, 12 millimeters from the top to bottom, or yep, 12 millimeters from the screw part of the screw. How do we call this part? Wait. Parts of the screw. Okay, with all the double E. Here, there we go. Thread length. Oh, okay. Yeah, there's so much more things. Threads, crease, major diameter, minor diameter, the tip thread length. Yeah, the thread length is what I'm referring to. The thread length is 12 centimeters. Yeah, perfect. So I have my screws right there. I will pack this away. Oh, I can already see that my table getting messy right here. Give me a second. Okay. If we no, that's what I need to know. Good. If we now screw, if we drill the holes now, we want to remove, and we want to remove 12 millimeters. The screw won't go all the way of the 12 millimeters, which is good because it can't even, there's not too much material left for the screw to go to. Okay, good. Maybe I'll... Wait, did I write this code wrong? I just read it right now. Oh my god. Discord. Damn. Why aren't you guys telling me that? Come on. Let me just check some messages for a second. Okay. So, would be really cool to have the parts printed now, then we could just throw in the next ones. It's also always the time you have, like, you print started and you just want to get it now and don't want to wait for the whole thing. Yeah, so let's see, we have one active viewer, which is probably myself. Yeah, what can you do? So yeah, I streamed 2 hours. Now I stream 1 hour more and then the print should be finished. I will take a look at it in 15 minutes again. So 20 minutes, 2 hours and 20 minutes in the stream, then I'll take a look at it. So now we have our screw heads right there. Now we need to widen the hole a bit more. And also here the second extrude will only be for, so we remove that extrude and this will get a separate one. Nope, I want to select this one. Extrude. So we have our bottom plate. It will be 5 millimeters. Yeah, it has to be 5 millimeters. Just like that. And there we go. Yeah, it has to be 5 millimeters. Okay, the audio is still good. I was scared there for a second that my audio wasn't on. Just like yesterday for the first 20 minutes. But no, we're safe. Solid, and we new like that. There we go. So the other one will be completely through, but this the right side won't, because that is where the motor will be. And yeah, the motor mount is finished so far. And then we need to determine the radius. We need for the servo motor the hole, and I think it's around 2. If we go from the center right here, yeah, we can make a 1.5 hole. 1.5 is a bit too small. We need to watch out that this to 0, 0, and then move it in that direction. So we theoretically only need to from here to here. If I edit out the sketch, and I will make a few points right here. 1.5. I need at least 15 millimeters in length. Would be the best, but I don't think I have the space for the 20. We theoretically also could cut a bit off here, so maybe let's make it actually just 1.5. Yeah, 1.5 would be a bit better, I think. Oh, and yeah, I also realized we don't need to make the holes from the complete outside, because then it wouldn't be accurate. We need to 15. Like that. And from here to 15. Now we just have to make sure that the distance from here to here is always 15 at least. Now I'll make it 16.5. $15. 15. And now if I go from here to here, the radius that I have here is how many degrees? How many degrees are that? If that right here are, I think 90 degrees will be good enough. Yep, that should be fine. Because 90 degrees we theoretically don't need, not just theoretically, we don't need 90 degrees. We only need 45, so that should be more than enough. More than enough. So then we will also scale this one to how can I make this like a direct way? I'm a bit stupid, I think. You know, I think I don't just think that. I'm not stupid, but I could have gotten a better idea there. With a diameter of 30. Oh yeah, that's the diameter of the thing as well, so let's make it 30. And then we go and here a point and here a point. Then we go ahead and like there a line and here a line, and that's a much cleaner way. Yeah, let's just go. That's awesome. So now we can go here and set it 90 degrees. Let's make this 3.5, 30, or 33. The length from here to here. Yeah, it's still 15. Good. Yep. Nope. I don't want to commit to that. So this will also be all the way through to the bottom. Remove through all and apply. Does not look the best, but should work quite well. Oh man. Okay. Okay, so we have this done. I think from now on we just have to print it, maybe make some changes to if I see that this is like not good. If I would see that, then I'll go and just change that, the print, or like file it away with, or clip it away with here those knives, so I have some magnet stacking is stuck to that here. The magnets are also for a different project, which also can be very interesting in the future if I get that going. Also will be an automation, so don't miss that. And if you're new to the stream, I would appreciate a like and a subscribe. But yeah, so let's go ahead. We could already export this. This is already done. Why is it? Why does it have a different color? Okay, I think that's just how it is. We now could, for the rest of the time, we can make an assembly, create a part studio, create assembly. We will call that assembly the hand, and now we will try to assemble all of that. I struggle with that too, with assembly things. So let's see how we will be able to perform here. So we have all the parts that we need. Let's start with put that to the side for now. Oh yeah, that's a completely new part. Wait a sec, let me move. Oh no. Delete. I don't want to add a new part to that, I want to add this part. Means that I have to make an add merge scope part 1. That's why it looked so different. So let's go and put this to the side like that. Drag this to the other end of the project because we don't need it right now. So what we can do now is go in here and make some connection joints. No, first of all we need to add all the connections. Revolute. Oh, we can edit the orientation. Oh man, I could have saved so much time with editing the orientation of those Revolute joints, or of those made connectors, like with orientating their, flipping the orientation. Oh man. Let's go ahead, make that. Why didn't this one? Oh yeah, because I selected the wrong thing. Like that. And now we just need to create here those. Let's go ahead and then this one. So to now make the revolute, we can just select this and this one. Oh, that's perfect. That's so good. Let's make just solve. Don't even have to play a lot with those. Then we make another revolute, which will be this and this one. Let's click also on solve right here. Oh, look at that. Look at that. You can finally see that it fits together. Oh my god. But it's still a bit wonky down there, so we have to see how this turns out on the 3D print. I mean, the current design, they're not going like all the way in, but far enough to let's see how this works later in the 3D print if we assembled everything. And now what we just do is we select plane here and we select a plane there. Maybe we can just quickly remove them, that and that. And now if we just can actually enable them again, the fingers. And now when we go ahead and go in the fastened. This and this. You could click solve. This won't just make anything, do anything. So now what we will have to do is to put this that axis which is up here 5 millimeters upwards. Okay, then I guess 10. No, maybe not. Maybe I just have to put this my bolts here correctly. Wait, maybe I think I selected him the wrong side. If I just flip him around and then go ahead and fasten that one and that one. That one we don't need. We make an offset of 5 millimeters and it's perfect. Of course, you want to have a 0.5 millimeters of wiggle room in there, but that should be absolutely fine. Now if we go here, and then in the back we would probably need some way of fixating it here. Okay, there is. Now we have to see how we fixate that one. But that's the gripper so far. Damn, I really like that. That's just like 3D modeling for games, but you do something for real life. I like that much more. It takes much more time to get it functional and printing and everything than in a game, but it's much more fun in the end and much more fulfilling, at least for me. So there is no bad decision I made from switching from game making to this content right here. Other than that, I see that this one is not aligning correctly. Why is that? Is that just the top hand being a bit broken? And 35. If I now go into the bottom hand, I go onto the 17 and 17. Then I guess there's the problem. For some reason these connections are not completely in the center for both. I think they're the center of math of no, that can't be. The center of path should be more more like here. Yeah, center of math should be there. Let's just check that. Doesn't take long. So not at the top, so let's remove that one really quick. If I go ahead and take a look, If I go ahead and select this one, let's see what this is doing to my offset. I press on move. I want to press on the x-axis. I want to move it minus 0.5 millimeters. Then I want to move it in the positive 1 millimeter. This is still not the right thing. 0.5 is the right thing. Then I think their length isn't the right. If I'm seeing this 80, and then the sketch 0 is already sucking into my chair like that. Please remind me if I'm like sitting like a little chump. So yeah, no, there's no difference. Center is, I think, the same. And I might have found the problem. Well, not directly the problem, but one thing why this might be a bit goofy. 0. Then you select the 0 and then you on that. No, it's completely centered though, I don't get the point. No, this is fine. So if I make this to 0, should be no difference. There should be no difference. This is completely on the center. 17 to there, 17 to there. Then I don't get the point. Well, I get the point, but I don't understand really why. Oh, that's fucking cool. Sorry for swearing. It's so cool. Just designing something and then seeing, just putting it together here. It's kind of, I don't know, like imagine building your whole factory in like a video game, or imagine playing a video game when you could learn how to do a CAD modeling software and build like machines in CAD and sell them at some point. Oh, that would be so cool. But I'm doing that. No, I'm not selling the machine. It will be all open source. Here the robot arm, and you will probably get it open source, because I would have to make like a license in Germany if I want to sell something. So there will be, for probably the next 1 or 2 years, I will just make open source stuff. Yo, thank you, Hydro. You're new to the stream, right? At least I never saw you here. Do you know about CAD modeling? If you do, I would maybe you can help me with some stuff here. If you look at that, you probably don't like it if you're somewhat into CAD modeling. You see that right here? I can't change it, because if I want to change it, my gear is at a completely different spot. See? Oh man. So, we have the hand right here, and another 30 minutes, then the 3D print should be completed, at least for the 2 fingers. And then we should have this where I can play around with in a better version. Oh yeah, and you recommended. That's nice. Yeah, most of the time when I spoke with someone here in stream, I think you're actually the first guy in the stream that found it through the homepage. At least the one who chatted in the stream. That's cool. Other than that, also my friends came in, but they came in because they saw me on like Discord. Not sure about kit modeling. I'm just a software dev for now. Maybe I would learn it later. Yeah. It's. I mean, my channel. You probably found it because my channel is still recommended on YouTube as a game development channel, and in that department, because my past 3 years on this channel were mostly game development, or like, at least like the past year I uploaded was game development, and oh, that's cool. Join a Discord. I think then you're the first person that joined the Discord that's also not my friend. You break like world records here. You should tell me if the link still works. I haven't updated it in a long time. I can actually just do that. Wait here, let me go to the description. And the Discord link, I hope it's still the same. I think the link changed a bit. Yeah, I changed it now. You should have the right link in here. Yeah, anyways, we have now the problem here. Wait, I think I can. Let me just try out if I can rotate actually the things, right? Because we should be able to do that. Or with the Revolute mate here, I should be able to. Can you? Oh, it works! It works! Yeah, kind of. Yeah, I updated the link just a second ago, so it should work. I hope. But if I update my stream right here, I can just check if it works. Oh, now it should work. Oh, yeah, it should work. Oh, thank you for the like, man. Oh. That's so cool. Hey, how are you doing, man? So, now we can set here. I already played around with it, with this functionalities here a lot. We can make, wait here, gear relation. Mates, then I select, wait, let me see that, the first and this, the rest we don't need so far. This gear. How do I? Okay, I have to take a look at that. That's interesting. I saw on a few YouTube videos. I found like a Chinese guy in like 1 or 2 weeks back. He has like 5,000 here CAD models with some just mechanical hacks. It was like a Lego building, but he was doing this in this CAD modeling here. So It's so cool. He just made animations with the same music clip down it, like 10 minutes long of some thing spinning and then another mate or gear was rotating. So cool. If I find this guy again, I'll definitely have to show him in the stream here. That was so cool. Yeah, here the gear. I'll take a look at that in a second. But then I'll add the first. No, now I need to know how I add this gear. Let me just check the description. Create a constant ratio of angular rotation between two mates with rotational degrees of freedom. Yeah, but I can select my gears. Rack on point, screw, linear. No, it's a gear. I think I really have to do a video or go through a video course. Damn. Oh, there you are. Full Stack Junior software. Damn. Have you been making games or just like normal software? Really interesting. Like for me, last 3 years or almost 4 years now, I made games with Unity for the most part. I also tried Godot and Unreal Engine for like 2 or 3 months. But I made like only game development. And yeah, not much more. Here on the sides I was maybe like trying with Visual Studio a few new things and try to make a software and a software platform, like grabbing web requests or something, but never really made a big software other than in a company where I made like a how would you say this, an internship. Yeah. I've worked on backend game servers, web servers, and general backend systems far. Okay, that's cool. Game servers, I tried to make a bit of that. I tried to play around with that a bit, but very, very complicated, at least I found for me. And I tried Mirror. I don't know if you ever tried around with Unity or have tried with Unity. Wait a second, let me just reset my browsing relation. Yeah, that's way better. So okay, now I can read the chat actually. So haven't touched game graphics yet though. I get what you mean, yeah. Game graphics, I also didn't really touch that. I made like with Blender a bit of low poly, just extruding and removing some parts of a cube, and tada, you have your game character or like a goofy ship. And so I'm also not the best 3D modeler with Blender, but I really enjoy here the cat modeling. I not really enjoy it. I do it because it gives you good results, but I like the mesh so modeling software more. Yeah. You made game servers, web servers, and general backend systems. Your web servers, never really touched that. Probably had like the idea with a friend to maybe make like a website where we can upload some stuff. And game servers, you probably mean like for your own games or for like Minecraft and this kind of stuff. So yeah, if you ever played around with Unity, you probably know about Mirror, and that was which I used for like networking my games. And there you can like peer-to-peer and peer-to-peer you can only do that over Steam. And yeah, was a lot of work, and I didn't not really understand this. Now I have like my job where I go kind of like in this direction, but I'm still learning there. So I haven't worked with any servers or software so far, which is kind of sad, but I gotta learn first before I can go into the real world. So yeah, let's try and find this tutorial on gears, on shape, gear animation. Here, please don't just be a gear animation. I think it's also a tutorial. Does he speak? I don't think he speaks, right? No. Lucky he's not saying anything. Wait. How did he get his gear so fast? Wait a second. If I go in here, okay, good. So it's not as easy as he showed in the stream. Spur gear. Here. Yeah, okay, yeah. I'm fine with my custom gear right now. So let's see. I want to see the assembly part. This is parts. Yeah. Revolut mate, I have the same. And if he puts, wait, how did you go and wait? Can I? If I now go in my assembly, and can I press like Alt to go, maybe Shift, Control, no. Okay, it's not that easy. Yeah, wait. Is there, Udemy? Let's see if there's a good. Just that I don't leak any details of my account or something. On shape. Let's see if there's anything. Hold on. CAD modeling. Complete guide to PTC on shape. I don't even know what PTC is. In CAD modeling. Oh, wait. You wrote something. Yeah, it's a single concept for the most part. The rest are most likely some abstract that just need some time to learn how it's designed, talking about servers, web servers, etc. Yeah, have you, can I ask how old you are and if you like really work there, or if you maybe like just like me brought this to yourself, like learned it to YouTube and maybe some courses online? Would be really cool. It's always cool to talk to people that know the same stuff as you are, or most of the time if they know more of you, which is most of the cases. It's really cool to ask some questions and learn a lot from them. Yeah, your PTC modeling, empower your engineering term. motion and mold analysis. Toggling between steady state and transient simulation. Okay. PTC. Okay. Yeah, then I think I'll take a look at that series here. Probably as a preview, you're right.
Hello and welcome to the Complete Guide to Onshape. My name is Matthew Alexander. I'm the lead instructor for this course, and I'm a professional mechanical engineer with over 10 years of experience. Throughout my time as an engineer, I've designed and created hundreds of components where key aspects to design and creation within engineering is through the use of computer-aided design.
It looks clean.
To design and creation within engineering is through...
Yeah. Looks clean, but it's a bit a lot of measurements.
Through the use of computer-aided design, also known as creation within engineering, is through the use of computer-aided design.
Did that was this? I just lost English there.
Also known as CAD. CAD can be conducted using many different software packages.
Okay, you just blew my mind with that. I haven't gone to a university regarding it. I was interested in that field when I was 13 and started learning since then. But I'm just wait, I can't read the rest of it because there's some heart in the way. Can I just open the whole thing? But I'm just about to land a junior position too soon. Yeah, that's so cool. For me as well, I found my job because I was making games for most of my time. And then just finding a job through that is like really cool. And most of the time they also pay very, very good. And I find it so cool that you can just learn something online and don't even have to go to university necessarily to get a job somewhere. I mean, I'm kind of like, in 3 years I probably go to university at my job. But yeah, that's a different thing. But I kind of like got my current job because I made like games too, so it's really, really cool too. But yeah, also you also brought this to yourself or to self-learning. So cool. But yeah, I probably will do something with servers in the next time too if I want to make some automation or something. Then communicating, and probably just one Arduino won't be enough to control a whole automation system. Then I need to like 5 or 6 Arduinos talking to each other. Wow, that would be really cool.
Onshape is one of these. Onshape is an amazing CAD package crammed full of useful features, has intelligent file storage, and is extremely intuitive to actually
loud,
use.
isn't it?
And this cannot be said for all CAD packages. What's more is that Onshape is going through rapid development to download a web browser. To top it off, this course covers the core features of Onshape, including 3D parametric design and technical drawing
Oh yeah, technical
creation. To ensure you truly learn how to use Onshape, this course is structured with over 50 videos on how to use Onshape, with over 15 exercises to get some practice, as well as capstone projects at the end of each section to pull all the information together. And don't forget that Udemy offers a 30-day money-back guarantee if you're not completely satisfied, so you've got nothing to lose. We hope to see you enroll and enjoy.
Yeah, that's cool. Well, we can already do the first. Yeah, that's cool. I think I'll save that. Here, can I put this? I just put that here. Why did I just close Onshape for that? Wait, where did Onshape go? There it goes. I just opened a new tab. Perfect. Yeah, I really have to get in this. I really have to make this course. It's not too loud. Yeah, okay, I closed it now, so I don't know, do I speak a bit too loud? Yesterday I played around with my audio a bit. Maybe I speak it a bit too loud. I can maybe put the microphone a bit further away, or is it fine as far away as it is right now? So this rotates. Yeah, let's see how we connect the gears in the end. That's what I want to see. And then okay, yeah, I get how that works. Wait if you... Wait, what did he do to make it work? Yeah, I think I have to. It's also fine. Okay, thank you for letting me know. Then I just have to take that one and that one, and then the gear ratio is 1:1. So theoretically, I should be able to. Kind of do that, but then I at least know that I have to put some limits in there. So maybe if I it does something. But I'm not sure if that is actually what I want, because 0 degrees. Oh. Not sure. Yeah, like I said, if I go to 0 degrees here, and the maximum should be 90. I don't know where where it stops. What is that now? Okay, I think I will delete the gear for now and try that in a second. Wait, what happened? I just... Enable the parts again. Everything is broken, perfect. No. Oh man. I broke everything. Too excited to try out the mate connectors. Oppa, no, I want to. Hey, that that is not what I wanted to do. I think that they mixed something up there. So for the second one, I want to have here that one. this and this one. And if I rotate it, at least the thing itself doesn't spin anymore. It's completely offset, but no. Yeah, probably because I selected the wrong. Okay, so now, yep, there we go. But if I go back in here, I have my limit. Maybe I'll just turn that off for a second. And that's not what I... Everything rotates. Hey guys, I'm back in a second. I'll check the 3D print and see if everything is still fine. See you in a bit. And I'm back. There we go. See this part right here? Perfect. Oh no, they don't fit. Okay, they fit better together than the last one. Oh, so cool, so cool. Okay, now we just have to print the next one. We can just... Yeah, the cover is rotating. And it's so funny sometimes. I'm not sure how long was it ago. 1 or 2 months ago, I designed also something. Wait, I show you. Here. There we go. There I put it. Here, my plan was, and still is, to build a folding machine. Like a thing where you can give a paper in, and it gives you like something folded out. Like paper crafts. For example, you give it like a paper in, a usual, a paper. Okay, perfect, I don't have a paper right here. Let's say you give a paper of this normal book size here. It's A5 paper. And then you can feed it through a machine and you get out a paper plane. And it maybe just throws it away. Maybe you have seen something like that online. And this would be some project that I would be interested in building in the next few months. First I will finish the robotic arm, and after that there will be some automation systems, which I'm pretty interested in. And this was a part, or like the first module, folding the paper. You can give like some paper through it, and you see you have some railing in here, and some railing, like a curved out roll here, and some roll with some spikes around it. And if you feed it a paper, like this one, see it's not folded or anything. If you give it through like that, let me go through here. If you roll it through it, it gives you like a nice and clean fold, and it's now easier for you to fold it. So a machine that after that just puts the paper, folds it over, and doesn't have to apply much pressure or do it with too much precision. So that's really cool. And there it was so funny. I was trying to animate all of that, and I rotated this, and it's all of a sudden the whole thing was rotating around this one joint. So funny to look at. Maybe I can open this in a second, and maybe it's still bugged because I didn't fix this or something. But yeah, definitely be some funny stuff happening in the next few months with me and this modeling software. Other than if I learn how to correctly use it, then it's probably boring as fuck. Nah, not that boring, but it won't be as as broken as it's right now. Yeah, I'll just read your text here. Oh yeah, that's really useful actually. It prevents the paper from getting broken when trying to precisely cut it. Yeah. I haven't modeled much further on that machine, but the idea was to have like a street. In my school there is one room that is, I don't know, like 5 by 5 meters big, and there's like this big of a production street, and I don't know what it does, but it's really cool. It's just like a really big, I don't know how to explain it. It's just like a big circle, and with many machines that do some stuff to an object. I never seen it work, but I definitely have to ask a teacher someday what this does, because it looks really cool, and I want to build something similar. I can make a photo and upload it here to YouTube, and maybe some people can explain what this is. Probably but just some some project from some students that worked with some companies that just try to market their product in there, but still really interesting. Or I don't know if you have seen some videos about people flying with drones through the Tesla factory. Not like illegal, but they go through. Tesla gave them permission here in Berlin, in the Tesla factory, to fly with drone through the like the way that a normal Tesla car would take on its assembly. And it was so cool, like giant robotic arms lifting the car here, welding something in there, and just sticking the whole car together. Such a cool video. Wait, I can just show it, I think. Channel was like the Tesla space, yeah. Here they uploaded the fly through. See, where is it? Probably changed thumbnail. It's not too long ago, so Tesla here. There, no. Nope. Did I already see it, or? No, I think it was before this. A Tesla factory fly through, there we go. Yeah, 2 weeks ago. Oh, it was by Tesla. Okay. Wrong YouTube channel. Right. Yeah, that's my plan, to make like a micro version. I don't really have too much space here in my room. My parents won't allow me to put my sofa here out of my room to have more place for a building station. But we will move to our new home like in the summer or the end of summer, and then I'll hopefully have enough room in my room. Enough room in my room to build some stuff in my room. Or maybe my parents allow me to have like one room where I can build my stuff and have like a kind of workshop where I can stream out of and design and everything. That would be so cool. Yeah, that's the video here. Let's just watch through a bit of it. Just like to get some motivation for better quality work. Yeah, see something like that. That's so cool. I don't know, it looks cool on video. You see those like 5 arms working on the same thing here. So cool. I mean, it looks cool on the video, but I can imagine that when it looks so big on the video, then if you're in there, it's so massive. And I would really like to at some point maybe get some, how do you call it, some a tour through the factory. Maybe if I get enough subscribers here, Tesla will allow me to go on a mission with them to visit the factory. Yeah, the drones hit one of them, then yeah, okay, I think the giant robotic arms are a bit scarier, but yeah, it's so cool. Just look at that, it's completely automated. Other than this, those parts right here. But most of the factory is completely automated. I find that so fucking cool. Of course, some people lose their jobs and everything, and that's sad and all. But if you look at it from a technology standpoint, it's so cool, I think. This looks so unreal. Yeah, okay, let's keep working, but something like that. I think you get my idea what I want to do with this channel. But yeah, so before we now assemble all of that, I want to now make a print ready. Let's just download that right here. Export to my folder here. Hand top and bottom, and here the hand. Right, just have to complete the sketch and then export. Then I can also already open Cura. It will take a long time to open. Hey. Oh, it's actually really fast. Yeah, I opened it before. That's probably why. We just delete here the finger file already out of there. Now we just top and bottom hand and just put it in here. Is it just me, or do they look a bit small in comparison? Let me just put a finger in here for. No, it's just how big they are. So let's see how long this takes. Oh, 2 hours. Let's do crank down here on the. It's not even making a difference. Okay. But if I make it in 3. Okay. I don't really need too much precision other than for here. Yeah, then 1 hour and this is finished. I might do a stream like tomorrow where I assemble all of that. So, you know, I'll just quickly go to, put this in the 3D printer and I'm back in a second. And there we go, some of these. So now we have that in the 3D printer. That would be so cool. Yo man, thank you for watching. It's, I don't know, I think you're the only one. Yeah, you watched for a long time now. Yeah, I think I'll make the animation working and then I have to prepare for work tomorrow. And no, I wasn't in the gym today, so I have to get my steps actually in. Yeah, it's raining outside and I was planning to go out with my family, like for a walk, but like I said, it was raining and now didn't have much time. So here, I think it's the first one, right? Why is there oh no, did I just delete the... Why was there? Okay, let's just try. Okay, yeah, I don't think that's the right thing to rotate by. Okay, it still rotates. So let's see, we have this right here, yeah. And then this. Let's press solve. But I think the orientation of this mate connector is inverted. Like that, yeah, perfect. And we are back to normal. Like that. We are not back to normal. Oh, wrong button. Wait, I want to... Yeah, okay, it's... You can control which one should rotate by selecting the first part here. Okay, it's interesting. Now I just need to add those limits here incorrectly. 0 degrees and 90 degrees. That does not look like 90 degrees of limit. And 90 degrees. Oh yeah. Well, it's actually perfect. It's a bit slow, but it works. So, and also for the next one, for the second, now we know how it goes. We select just 0. Probably have to go like 90, minus 90 degrees. Oh, no, already. Or maybe not. Okay. I think we have to go minus 90 degrees. Solve. Rotate. Then let's see what happens. Then from 90 to 180. Okay. There we go. Can we also make this like to 90? Solve. and rotate it. Solve. Yeah, there we go. Oh, so cool, so cool. Now we just have to make this one here working. This and this. And then in theory, if we rotate one of these, of course we're just in theory, or we're in a practice and not in theory, because in theory this should have worked. Gear, then what's wrong with the gear? The ratio is fine. There was 18 by... Oh, whoopa. Where did it rotate? Okay. 18... Is it 18? Yeah. Divided by 18 is 1, right? 18 divided by 18, you can... Yep, it's 1. I was right, so I could have just left 1 there. But now if I were to move that one, I can just... No, that's not how I want to move it. I think I have to still move it over these connections. Not how I want it. Yeah, okay. Then I think I'll end the stream right here, and I thank you really much for watching. Don't know, I think you're the only one watching, but thanks to everyone who watched and liked the stream and everything. So cool. Then I'll probably see you in the next 1 or 2 days. I don't know if I have enough time over the week, or if I'll only stream from now on the weekends, and there I make like one big stream where I stream like 5 or even 8 hours at a time. And I guess then I see you in the next stream. Have a good night, and not a good night, I think it's still enough day left, but have a great day, and yeah, see you guys. Bye.